Hello student, I am Sachin Gupta and I welcome to you on my YouTube channel where I am uploading the video of the mathematical concept. Today I brought to you most important concept of the differentiation for class 12th. And student, it's before we move on towards our lecture, I want to say that please like and subscribe my channel, because if you do so, then you give me as a feedback and I make more and more video for you. And today I take this content of exercise 10C of S.Aggarwal, which is the 13th edition of the S.Aggarwal book, and which is printed on 2023. Now we already write here some formula of the differentiation which is used in exercise 10C. So student, let's see one by one these formulae. Here student, I write the differential of sine inverse x is 1 upon under root 1 minus x square. Differential of cos inverse x is minus 1 upon under root 1 minus x square. And differential of tan inverse x is 1 upon 1 plus x square. And differential of cot inverse x is minus 1 upon 1 plus x square. And student, the differential of sec inverse x is 1 upon x under root x square minus 1. And differential of cosec inverse x is minus 1 upon x under root x square minus 1. So student, these are the formulas of the differentiation of inverse trigonometry which is used in exercise 10C. I write here some question of exercise 10C and solve them. Here student, in the exercise 10C there are 19 questions in which I take here only 11 questions in first time, and I solve these questions one by one. So student, let's see question number 1 is here cos inverse 2x. As student, I already say that whenever any type of function is given to us, then we take the function y is equal to given to function. So I write here let y equal to cos inverse 2x. Now we differentiate it. So apply the d by dx on both sides, as we are differentiating with respect to x student. So I apply d by dx. As student, we know that the differential of cos inverse x is minus 1 upon under root 1 minus x squared. Since here student, in the place of x is present 2x, so I write here whole of square 2x, whole of square of 2x, and I again differentiate 2x by applying chain rule, because we are differentiating with respect to x, not with respect to 2x. If we are doing differentiation with respect to 2x, then this is our complete answer, and we further don't differentiate. So remember that we are differentiating with respect to x, so we differentiate 2x again. Now I write here minus 1 upon under root 1 minus, if you do that is whole of square of 2x, then square of 2 is 4 and a square of x is x square, and you differentiate when 2x with respect to x, then its value is 2 times 1. So this proper value is become minus 2 upon under root 1 minus 4x square. This is our first answer. Now we go on question number 2 student. So I write here y equal to tan inverse x square. Now solving on question number 2, I write d by dx on both sides. Now student, we know that the differential of tan inverse x is 1 upon 1 plus x square. Since in the place of x square here present x square, so I write here square of x square. And student, we know that whenever we differentiating with respect to x and here present x square, so I differentiate x square again by applying chain rule, then it's become something its differential of x square is 2x student, and when 2x is multiplied by 1, then it's become 2x, and this function is come as well on the denominator, so it's become 1 plus x raised to the power 4. This is our second answer. Now we go on question number third, student. So I let y equal to sec inverse under root x. I apply both side d by dx because we are differentiating with respect to x. Now student, we know that the differential of sec inverse is 1 upon x, and in the place of x here present root x, so I write here root x and under root x square minus 1, and since here in the place of x is present under root x, so I write here square of under root x minus 1. And student, since I differentiate with respect to x and here present root x, so I again differentiate root x. And student, if you know that differential of root x is 1 upon 2 root x, so I write this function as well as, student, if I square the root x, then square and root get cancelled to each other and it's become x minus 1, and square differential of root x is become 2 root x, 1 upon 2 root x. And when we multiply this root 2x, this root x and this root x, then it's become x. So I write here 1 upon 2x under root x is minus 1 is our answer. Now student, I take the question number 4. So I let here y is equal to given here sine inverse x by a, and we differentiate it. So I apply d by dx on both sides, and student, I know that the differential of sine inverse x, I write here formula for your knowledge. This is 1 by under root 1 minus x square. Since here in the place of x is written here x by a, so I also write here in the place of x is x by a, then I write here whole of square x by a, and since in the place of x is present x by a, so I differentiate again x by a by applying chain rule. And when we solve this fraction part, then I take here 1 as a LCM, and this become x square upon a square, and a square is multiplied by here 1, then it's become a square minus a x square and whole divided by a square. And when student we take under root of a square of the denominator, then it's become a, and this a goes upside, then its value is become a upon under root a square minus x square. And when we differentiate x by a, then I take 1 by a as a constant outside of this function, and differential of x is become 1, and this a get cancelled to each other, then it's become 1 upon under root a square minus x square. This is our fourth answer. Now we go on question number 5. So I let y equal to tan inverse log x. Here student, I again apply d by dx on both sides because we are differentiating with respect to x. Now student, we know that the differential of tan inverse x is 1 upon 1 plus x square. In the place of x is written here log x, so I write here log x whole of square, and I again differentiate log x because in the place of x here written log x, so I differentiate log x again by applying chain rule, and differential of log x is 1 upon x, so I write here this function as well as, and its differential is 1 upon x. So our total values become 1 upon x within bracket 1 plus log x whole of square. You can apply here big bracket. This is our fifth answer. Now we go on question number 6 student. Question number 6 is, I take y is equal to cot inverse e raised to the power x, and I solve here. I apply d by dx on both side, d by dx on both side. Then it's become something. Differential of cot inverse is, student, differential of cot inverse is minus 1 upon 1 plus x square. Since in the place of x here represent e raised to the power x, so I square of e raised to the power x, and again differentiate e raised to the power x, because student, I tell you before that whenever in the place of x occurring any other function, then we differentiate it again. So I again differentiate e raised to the power x by chain rule, and here apply 1 plus e raised to the power 2x. When you multiply here bracket is inserted between x and 2, so 2 is multiplied to x and it's become 2x, and differential of e raised to the power x is e raised to the power x, then it's become e raised to the minus time e raised to the power x 1 plus e raised to the power 2x. This is our sixth answer. Now we go on question number 7, student. So I write here y equal to log tan inverse x, and apply d by dx on both side, As student, we know that the differential of log is 1 upon x, so I write its differential is, in the place of x here written tan inverse x, so differential of log x is 1 by x, so I write here 1 upon tan inverse x. Now we differentiate again to tan inverse x, because in the place of x here present tan inverse x, so I differentiate it again, and tan inverse x I write as well as 1 upon tan inverse x I write as well as, and differential of tan inverse x is, I know, student, 1 plus x square. So this is our total answer. Now we go on question number 8, student. Question number 8 is I let cot inverse x cube and solve, apply d by dx on both sides, because we are differentiating with respect to x. Now student, we know that the differential of cot is minus 1 upon 1 plus x square. Since here in the place of x is present x cube, so I is square of x cube. I write here square of x cube, and I again differentiate x cube by applying chain rule. Differential of x cube is 3x square. Differential of x cube is 3x square. Then its value come as well as, when you do square of x cube, then it's become x raised to the power 6. This is our eighth answer. Now we go on question number 9. I write here y equal to sine inverse cos x, student, and we apply d by dx on both side, then it's become something like d by dx of sine inverse cos x, and I know the differential of sine inverse is x is 1 upon under root 1 minus x square. Since in the place of x here present cos x, so I do square of cos, like this. So, and student, I differentiate cos x again by applying chain rule. We know that the differential of cos x is minus sin x, and when minus sin x is get multiplied to 1, then it's become minus sin x, and it's become student, I know that 1 minus cos square x is sin square x, and when we solve under root 2 square, then it's become sin x, then our answer is minus 1. Now we go on question number 10. Question number 10, I let here student y equal to 1 plus x square and tan inverse x. I apply d by dx on both side, d by dx on both side. Sorry student for disturbing. Now we apply d by dx on the 1 plus x square and tan inverse x. Here student, I see that here two functions are occurring, so I take it first and second and apply the formula of first second rule of the differentiation. Then I write the first function d by dx of second function and plus second function d by dx of first function. Now student, I write 1 plus x square as well as, and differential of tan inverse x is 1 upon 1 plus x square, and plus I write here tan inverse x as well as, and differential of 1 is 0, differential of x square is 2x. Now student, these two functions are same, so I cancel it and it's become 1, and tan inverse x and plus 2x is multiplied by tan inverse x and it's become 1 plus 2x tan inverse x. This is our answer of question number 10. Now we go on question number 11. Student, see here, question number 11 is y equal to tan inverse cot x. Student, if I write this function like I write in the place of cot x is tan pi by 2 minus x, and this tan and this tan get cancelled to each other, then our function is changed into pi by 2 minus x, and now we differentiate both sides by x, d by dx pi by 2 minus x. We separate the we give d by dx separately inside the bracket, then it's become something like d by dx of pi by 2 sorry student, and pi by 2 minus d by dx of x. And student, we know that the differential of constant function is 0 and differential of x is 1, then its value is 1, is answer our. Here student, I write 8 more question of exercise 10c, and which is from question number 12 to question number 19, and I solve these 8 question one by one, and right here question number 12 is y equal to log sine inverse x raised to the power 4. Now we apply here d by dx on both sides, and d by dx on both sides, then it's become something like student, a differential of log x is 1 upon x, so 1 upon sine inverse x raised to the power 4 goes downside, and we differentiate again student sine inverse x raised to the power 4, x raised to the power 4 again by applying chain rule, and I write this function as well student, sine inverse x raised to the power 4 I write as well. And when we differentiate sine inverse function, then its a differentiation is under 1 upon under root 1 minus x square, and in the place of x square here present x raised to the power 4, so I square the function of x raised to the power 4, and again differentiate x raised to the power 4, then it's become something like sine inverse x raised to the power 4 I write as well as, and it's become 1 upon 1 minus x raised to the power 8, and it's become 4 times x cube. And when we multiply this, then total function is become 4x cube whole divided by under root 1 minus x raised to the power 8 and sine inverse x raised to the power 4. Now this is our answer of question number 12. Now we go on question number 13. It's before I erase it student. Now we go on question number 13. Let y is equal to cot inverse x square whole power cube. Now we apply d by dx on both sides, student. D by dx on both sides. So it's become something like a differentiation of x raised to the power n. I take this function as a x. I consider this function as a x. Then it's become x raised to the power n. Then the differential of x raised to the power n is n times x raised to the power 3 minus 1, and I again differentiate cot inverse x square, because in the place of x here is present cot inverse x square. Now I write it 3 and cot inverse x whole of square. And student, I know that the differential of cot inverse x square is 1 upon 1 plus x square, and in the place of x square is present in the place of x is present x square. So I square the square of x square, and I again differentiate x square, student, because we apply here chain rule. And differential of x square is 2x, and when we 2x multiply by this 3, then it's become 6x. And I write it is this function is as well as, and 1 plus x square of squares become x raised to the power 4. This is our answer of 13 number. Now we go on question number 14, student. Question number 14 is I write here y equal to tan inverse cos under root x. Now differentiate, so I apply here d by dx on both sides, d by dx on both sides, student. And student, I know that the differential of tan inverse x is 1 upon 1 plus x square, 1 upon 1 plus x square. Since in the place of x is present cos under root x, so I write cos under root x in the place of x and do its square, and I differentiate again, student, cos root x by applying chain rule. Now this function come as well as here, so I write here it, and differential of cos root x is become minus sine root x. And student, we apply d by dx on root x again by applying chain rule, then it's become differential of root x is 1 upon 2 root x, which I write here 1 upon 2 root x, and this function is, when I multiply by 1, then it's become minus sine root x and 1 plus cos root x whole of square. And this come on the before of the function, then it's write as 1 upon 2 root x, and this is our answer of question number 14. Now we go on question number 15. Question number 15 is, student, I write here y equal to tan sine inverse x. We apply d by dx on both sides, and differential of tan is sec square x, student, sec square x. So I write sec square x in the place of x is present sine inverse x, so I also write in the place of sine inverse x. And since here the in the place of x is sine inverse x, so I differentiate sine inverse again, and differential of sine inverse x is 1 upon under root 1 minus x square, and when we multiply by this one, I write here firstly, because you don't confuse, 1 minus x square I write as well here, And student, when we multiply by 1 this function, then it's become something like this: x square and sine inverse x and whole divided by under root 1 minus x square. This is our answer of question number 15. Now we go on question number 16. Question number 16 is, student, question number 16 is y equal to e raised to the power tan inverse under root x. I apply d by dx on both sides, student. As student, we know that the differential of e raised to the power x is does not change. So e tan inverse root x come as well as, now we differentiate tan inverse root x again. Why I differentiate again, student? Because we apply here chain rule. Because we here apply because we here differentiate it again, because we differentiating with respect to x. It so e tan inverse x under root x come as well as, and differential of tan inverse x is 1 upon 1 plus x square. Since in the place of x is present under root, so I write here under root and its square, and I again differentiate root x, and this function is become e tan inverse root x I write as well as, and it's become 1 plus x. And student, we know that the differential of root x is 1 upon 2 root x. This is our answer of 16. Now we go on question number 17. Question number 17 is under root sine inverse x square. Under root sine inverse x square. So I differentiate it, student, and apply d by dx. As student, we know that the under root can be written as an exponent form like this: sine inverse x square whole power 1 by 2. This become the formula of x raised to the power n. Then power come before of the difference, before of the sine inverse x square and whole power, it's get 1 less whole power, it's get 1 reduce. So and student, I again differentiate sine inverse x square by applying chain rule d by dx of sine inverse x square. Then 1 by 2 I write as well as, and sine inverse x square I write as well as, and this become power minus 1 by 2. And when we differentiate it, then it's become 1 upon 1 under root 1 minus square of x square. And we differentiate x square again, and we differentiate x square again. Then differential of x square is 2x, and this 2 and this 2 get cancelled to each other. Then it's become something x upon, and this power when this function goes downside, then this power is become positive, and here power is 1 by 2. So we apply under root. Then it's become sine inverse x square and under root 1 minus x raised to the power 4. This is our required answer. Now we go on question number 18. It's before I erase it. Here, student, question number 18 is if y equal to sine inverse cos x plus cos inverse sine x, then we have to prove that dy by dx is minus 2. Simply we have to differentiate it. So I take this y equal to sine inverse cos x and plus cos inverse sine x. If student, I change this function in the terms of sine, then I can write cos in the terms of sine, like as sine pi by 2 minus x, and this cos inverse I write as well as student. And if I want to change this sign in the term of cos, then I can write it cos pi by 2 minus x. Now student, why I change this function in sign and why I change sign in the form of cos? Because if I change sign in the cos, then this cos and this cos get cancelled, and this sign inverse also get cancelled. Sorry, this cos and cos inverse get cancelled. Then it's become only pi by 2 minus x, and plus this sign and this sign and this cos get cancelled, and remaining terms are pi by 2 minus x and pi by 2 minus x, which become half pi plus half pi become pi, and minus x and minus x become minus 2x. Now we differentiate it with respect to x, then it's become something like this. And when we differentiate pi with respect to x, then the differential of constant function is student 0, and we take 2 outside of the differential of x, then it's become minus 2 times 1, that is minus 2. Hence I prove that the value of dy by dx is minus 2. Now we go on question number 19 student. Now we go on question number 19, which is last question of this exercise. Now we go on question number 19. Here we have to given this function, so I take its LHS part. We have to differentiate with respect to x of this function student, because here write d by dx, so I differentiate this function. And student, we know that whenever we have to given two function in subtraction and differential is outside of this function, then we give differential both these function separately. So I write d by dx 2x tan inverse x, and d by dx log 1 plus x square. Now student, we know 2 is a constant, so we take it outside of the differential of this function. And when we differentiate it, then x is here our first function and tan inverse x is our second function. So I write first function d differential of second function, and second function differential of first function. And here I write minus as well as, and differential of log x is 1 upon x square, so 1 upon x square come as well as, and I differentiate it 1 plus x square again by applying chain rule, then it's become x, and differential of tan inverse x is 1 plus x square. This tan inverse x come as well as, and differential of x is 1, and 1 upon 1 plus x square I write as well as, differential of 1 is student 0, and differential of x square is 2x. Then if I multiply this 2 in both these two terms, then it's become 2x upon 1 plus x square, and 2 tan inverse x. When we multiply by 1 tan inverse x, then tan inverse x only is remaining, and when we multiply 2 by it, then 2 is also come with it, and this function is become 2x upon 1 plus x square. Now student, if you are watching that these two terms are same but have opposite sign, so I cancel these two terms, and the remaining function is only minus 2 tan inverse x, which is here. Sorry student, here is a positive sign, so I also write a positive, which is have to prove in right hand side 2 tan inverse x. So student, if you like this session, then please press the like button and meet in the next lecture.